Today we begin with the new chapter, that is work, energy and power, that is chapter number 6. Now first of all we shall here discuss about the scalar product, that is a mathematical tool which is utilized here to study this first topic of work. Okay. Now see, two vectors when they are there or given, if they are multiplied to get a resultant quantity as a scalar quantity, there are two vectors and you are multiplying them in such a way that you get a resultant as a scalar quantity, then this kind of product is called the scalar product. Okay. Say for example you are given two vectors A and vector B, and if you multiply, that is a dot product as such, it is scalar product or a dot product. So A dot B is defined as AB cos theta, where this A is the magnitude of vector A and this B is the magnitude of vector B. So A dot B is defined as magnitude of A multiplied by magnitude of B multiplied by cos theta, and here theta is the angle between two vectors A and B. So we can write A dot B in this way also, A into B cos theta. Now what is A? A, I have told you that it is magnitude of A, and B cos theta is component of B on A. Or you can rearrange in the another way also. You can write it as B into A cos theta. You can also write this A dot B. You can write this A dot B as, you can write it as B into A cos theta. So what will happen? Magnitude of B multiplied by the component of vector A on B. So two ways are there to define, it is one and the same. The value which we are getting is one and the same. So either way you can define. So here we can say A dot B is nothing but B dot A. You can write it as A dot B is equal to B dot A, which is a commutative law is followed. Now if you take distributive law, then it is A dot B plus C is nothing but A dot B plus A dot C. Okay, you can easily open the bracket. Now if you take the dot product of unit vectors, say for example you have unit vector I hat. So I hat dot I hat. The magnitude of I hat is 1 unit. It is a unit vector, so its unit is, its value is 1. So 1 into 1, and the direction of vector I cap with itself, or we can say angle of I cap with itself is 0. The angle of certain vector with itself is always 0. So I dot I will give you 1 into 1 into cos 0, and that will give you 1. So I dot I will give you 1. Similarly, J dot J and K dot K will also give you 1. But if you take I dot J, then write the values of I and J. They are unit vectors, so their values are 1 into 1. What is the angle between I and J? Now vector I is in x direction, vector j cap is unit vector in y direction. So angle between unit vector I cap and unit vector j cap is 90 degree. So you write cos 90, and cos 90 is 0. So I dot j is 0. Similarly j dot k is 0, k dot I is also 0. Now if two vectors are given, that is ax I cap plus ay j cap plus az k cap. The other one is bx I cap by j cap bz k cap. Then just if you want to find the dot product, then multiply x component with x component, y with y and z with z, because I dot into I dot will become, I cap into I cap will become 1. J cap into J cap will become 1, K cap into K cap will become 1. So just you have to take the multiplication of respective coefficients of I cap, J cap and K cap, Okay, so AX, BX, AY, BY, AZ, BZ. If you want to take the product like this, AX into BY, try to understand. AX into BY you want to take. Take AX BY into I cap J cap. Now I cap and J cap will be 0, so that is insignificant. As said, we don't take that. Okay. So here one example is taken. Okay, here two vectors are given, I cap plus 2 j cap minus k cap, B is 2 I cap plus 3 j cap plus 2 k cap. Now here coefficient is 1, so 1 into 2 will give you 2. Then 2 into 3 will give you plus 6. Minus 1 here, it is minus 1, try to understand. Minus 1 into 2 will give you minus 2. Now just simplify, you will get the answer to be a particular value, that is 6 units. Okay. This way it is easy to find the dot product, just you have to take the product of the coefficients. Okay. Now we move towards the physics part of this chapter, that is first the definition of work. Okay. Now see, here one object is kept on the surface. Here, okay, on this surface object is kept. Now you are taking here by applying its force F in direction parallel to the surface. Direction parallel to surface, you are applying the force and the object goes from this position to this new position, and the displacement is nothing but d. Okay, so work is defined as force into displacement. Product of force and displacement is defined as work, where theta is 0 here between force and displacement. This is our simple example that we studied as such in your 9th standard, that product of force and displacement. Now try to understand, you are applying the force at certain angle. Now this is a general case. You can generalize it for any situation. Say for example, you have the object here and you are applying the force in this direction. You must have seen a child playing with a kind of toy. A thread is tied and he is pulling that with the help of a thread. The toy is making the displacement on the surface. It is not going to fly off. It will go in this particular direction. So the angle between the force and the direction of displacement is theta. So now you don't have to take the entire force in the direction of displacement. There is a component of force or some effectiveness of the force in the direction of displacement. Totally F amount of force is not acting in the direction of displacement. Try to understand. Only a part of force, that is component of the force in the direction of displacement, is acting, and that component of the force is F cos theta into displacement, that is d. So it is F d cos theta. Now as you know, force and displacement both are vector quantity and there is a cos theta. Okay, so this can be written as our dot product, which we have already defined. Work is equal to F dot D, that is a dot product of force and displacement. So now if you try to understand this case which we have studied earlier, then the angle between force and displacement is 0, theta is 0. So what will you get here according to our general formula, F dot D? Now F dot D is nothing but work done. So F d cos 0, it becomes F d cos 0, and F d cos 0 is nothing but force into displacement, which we had taken in your 9th standard. Okay, that was easy to understand, and you do not have the idea of cos theta and component. That is why it was discussed in a very simple way. Okay, so F dot D, that is dot product, is nothing but the work done, or we can say F d cos theta. If theta is 0, then we can say force and displacement are in same direction, then it becomes F d cos 1, that is F into d only. Okay. Now when can we say that there is no work done? When the displacement is 0, then no work done. When no force is applied, then no work done. Okay. When the angle between force and displacement is 90 degree. Try to understand, if cos theta cos 90 it becomes, then work done is 0. So whenever angle between force and displacement is 90 pi by 2, then work is not done. Now we talk about angles. Okay, if theta, that is angle between force and displacement, is between 0 to 90, that is pi by 2, work done will be positive. If the angle between force and displacement is between 90 to 180, then the work done will be negative. And at 90 degree, okay, at 90 degree the work done will be 0. Now when you try to understand this, say force and displacement are opposite. You can understand this way, that when the object is moving on the road, okay, in this particular direction, then displacement is in this direction. Now if frictional force, if you consider, then it will be opposite to this direction of motion. Then frictional force and the displacement, they are having the angle between them as 180, they are anti-parallel. So work done by the friction will be negative as cos 180, because there it will be cos 180 and cos 180 is minus 1. So work done will be FD cos 180 and it will be minus FD, or we can say negative work will be done by the frictional force. Okay, so this is all about the different work done and the definition of work done and the scalar product. Okay, now you try to read this part from the textbook. Okay, and we shall discuss the kinetic energy and other things in the next lecture. Okay, thank you very much.